Welcome to ThermalSpec Building Diagnostics. Please visit our website at www.thermalspect.com. ThermalSpec proudly serves southeastern Pennsylvania, New Jersey, and Delaware. So, why do we use infrared thermal imaging? Infrared thermal imaging is an advanced, non-destructive technology that allows us to show you things about your building that no one else can show you with conventional inspection methods. Infrared thermal imaging better determines the actual problem as opposed to merely identifying symptoms. We include this visual documentation within your inspection report, providing hard proof in full color. Have us perform an infrared thermal imaging inspection on your home or commercial property that you own or are buying, building, selling, or leasing. We're all familiar with the saying, a picture is worth 1,000 words. Here are some benefits of infrared thermography. It helps significantly reduce unscheduled power outages, detect problems quickly without interrupting service, assesses priorities for corrective action, minimizes preventive maintenance and troubleshooting time. It helps the client comply with insurance company requirements, check for defective equipment while it's still under manufacturer's warranty, and most importantly, it allows for predictive maintenance versus reactive repairs. In this thermogram, we see an electrical disconnect switch, more commonly referred to as a breaker. This image was taken during a routine inspection of a commercial restaurant facility. The bright coloration alerted the thermographer that there may be a potential problem. Upon further examination, after removing the panel cover and attaching electrical testing equipment to the circuit, it was determined that there was not a problem. Had this breaker switch failed, it would have cost the restaurant hundreds of dollars in lost revenue for the night. This breaker controlled the refrigeration unit where large quantities of meat were stored for that week's menu. Infrared thermal imaging for electrical systems can be used for power generation inspections, including exciters, 4160 connections, motor control centers and isophase bus ducts, substation electrical inspections including switchgear, breakers, transformers, and capacitor banks, overhead urban and rural distribution electrical inspections, electrical motor inspections, electrical faults before they cause a fire, overloaded and undersized circuits, circuit breakers in need of immediate replacement, loose terminals, and failed insulators. Here we see a representation of a handheld thermal imaging camera in use to evaluate two building exteriors. Below is a thermogram that is produced by a thermal imaging camera. Infrared thermal imaging for building envelopes and structures can be used for stucco and EIFS, or exterior insulated finished system inspections, thermal heat loss inspections for buildings, plants, facilities, and refineries, moisture contamination evaluations in buildings, condos, plants, and facilities, concrete integrity inspections, water heated concrete floor inspections for leaks and temperature distribution, evaluate the thermal performance of retrofits, locate radiant heating wires or pipes, detect delamination in concrete bridge deck, missing, damaged, and/or wet insulation, heat loss and air infiltration in walls, ceilings, floors, windows, and doors, water and moisture intrusion that could lead to mold, wood-destroying insect infestations, pest and wildlife problems, hidden roof leaks before they cause serious damage, under fastening and/or missing framing members, structural defects, and broken seals in double-pane windows. Here we have a thermogram of a commercial low-slope roofing system taken from the interior. Notice the dark purple areas in the center of the image and to the right. These areas were determined to be from moisture intrusion resulting from improperly installed seams on the roof surface. Thermal imaging documentation as well as physical inspection of the roof surface resulted in the roof covering being replaced at no additional charge to the client by the roofing contractor. Infrared thermal imaging for roofing systems can be used for flat roof leak detection for buildings, plants, and facilities. Identify water damaged portions of a roof quickly and accurately. Eliminates unnecessary replacement of good roofing. Plan for accurate budgets based on facts. Document problems before the warranty or bond expires. Can evaluate leaking roof penetrations and conditions conducive of ice damming. Here we have two thermograms of electric motors. Notice in the lower image there is a bright white coloring on the rotating shaft. This area has a higher temperature than the surrounding components and can be an indication of shaft misalignment or a worn bearing. Further diagnostics are needed in order to identify the problem. However, thermal imaging allows us to view these systems while under full operating load, and the systems do not have to be shut down or taken offline for us to conduct an inspection. This allows us to detect potential problems before there is a breakdown, which can result in thousands of dollars worth of lost man-hours in the event of an unexpected failure. Infrared thermal imaging for mechanical systems can be used for boilers, to inspect burners for flame impingement and burner management, look at combustion patterns of fuel, detect thermal patterns on boiler tubes and measure tube skin temperatures during normal operation or when a boiler is on standby, scan and record temperatures in areas of a boiler not monitored, scan the exterior of a boiler for refractory damage or locate warmer areas where potential refractory damage may occur, detect coke buildup in crude oil furnaces, power plant boiler flue gas leak detection, mechanical bearing inspections, unknown plumbing leaks, identify crossed hot and cold water connections, overheated equipment, shaft alignment problems, conveyor belt system wear points, and inductive heating coils. Thermal imaging provides great results for locating in-floor radiant heating systems. This is often helpful when a hole needs to be drilled or cut in the flooring where there is risk of damaging the piping. Leaks in in-floor radiant heating systems are easily identified with thermal imaging as well. Infrared thermal imaging for heating, ventilation, air conditioning, and refrigeration applications can be used for duct leakage, duct blockages or disconnects, compressor problems, cooling tower circulation, refrigeration unit seals, locate ductwork inside of walls or ceilings, condensate discharge, heating, ventilation, and air conditioning equipment evaluations, cold storage cooling losses, detect insulation leaks in refrigeration equipment, dangerous flue leaks, air conditioning compressor leaks, and damaged and or malfunctioning radiant heating systems. Thermal imaging can be used in a multitude of different areas in industrial applications. Here we see a thermogram of distribution piping inside a refinery taken as part of a routine maintenance evaluation. Infrared thermal imaging for petrochemical applications can be used for refinery process line insulation loss or leak detection, refinery process evaluation, heat exchanger quality and efficiency evaluation, furnace refractory or insulation inspections, furnace internal flame evaluations and tube inspections, flame propagation explosion analysis. Here we see a representation of a handheld thermal imaging camera being used to inspect a panel inside of a data distribution center. Below is the resulting thermogram. Notice the bright white and orange coloring in the junction box on the right. This can be an indication of a potential problem that needs further investigation. Identifying problems such as this can prevent failures that can result in significant man-hours to repair, dissatisfied customers, and potential loss of contracts due to downtime. Infrared thermal imaging for electronic equipment can be used for printed circuit board evaluation and troubleshooting, thermal mapping of semiconductor device surfaces, circuit board component evaluations, production type inspection of bonded structures, inspection of hybrid microcircuits, and inspection of soldered joints. Infrared thermal imaging for environmental applications can include the ability to locate old waste disposal sites, locate old buried tanks on industrial sites, and locate and monitor oil spills. Infrared thermal imaging for automotive applications can include motor racing suspension and tire contact diagnostics, as well as brake and engine system evaluations for performance and cooling efficiencies. Infrared thermal imaging for pulp and paper industry can be used to detect uneven heat distribution in Fourdrinier steam boxes, identify wet streaks or non-uniformity that can have adverse effects on paper quality, identify basis weight variations, monitor size press performance, analyze dryer temperatures to look for non-uniformity in dryers, monitor coatings to see that it is being applied uniformly to surface of the paper, analyze reel to find anomalies that may be introduced by pieces of process equipment connected to the paper machine, inspect chip piles for hot spots. Infrared thermal imaging for steam turbine and hydroelectric generators can be used to locate intralaminar faults in stator cores, monitor the effectiveness of repairs to damaged areas, help maintain quality control during stator core repair, and obtain a thermal image of the stator core that serves as a permanent record of the condition of the stator core following repairs. Infrared thermal imaging for miscellaneous applications can include the ability to detect RF heating in antennas, waveguides, guy wires, and frame structures, locate low-intensity sleeper fires on forest lands, remote sensing applications, locate non-uniform densities in hot mix asphalt paving, locate moisture and delaminations in marine construction. Thank you for viewing our video presentation. Contact us today at ThermalSpec Building Diagnostics to discuss having an infrared thermal imaging inspection performed at your property. Please be sure to visit our website at www.thermalspec.com for additional information.